let us discuss about the concept of reflection of sound, which we call it as an echo. What are different features of an echo, and what are the important aspects one has to remember as far as the echo formation or hearing the echo by an observer that is concerned. So, let us consider what is this echo first. Basically, it is the reflected sound. Sound whatever that is being produced by a sound producing source, traveling in a particular direction, striking a hill or a wall, whatever it is, if it is returning back after reflection, whatever the sound that can be heard by the observer, that is what we call it as an echo. What is the basic condition first of all to produce an echo? We in fact have a persistence time of hearing. For human ear, the persistence time, which of course we used to call it this way, the time gap that should be maintained between two successive syllables, whatever we speak, that time gap, which of course we people should have to be able to hear that sound very clearly, that is what we call it as persistence time of hearing. For human ear, the persistence time of hearing is 1/10 of a second, which otherwise we can call it as 0.1 second. So, first thing we should understand here is what is the persistence time of hearing. Persistence time of hearing for human ear is 1/10 of a second, that is 0.1 second as such. So, considering this persistence time of hearing, let us take here a source of sound and there is a reflector which of course reflects the sound. Sound used to go there to this reflector, strikes the reflector and comes back. Then suppose if an observer is standing nearby or adjacent to this sound producing source, he can hear an echo out of that. Even if a person is standing here and clapping, then the sound reaches that reflector and comes back after reflection. That same clapping, whatever he has produced in the form of sound earlier, can now be heard in the form of an echo. Now, when you consider the distance to this particular reflector from the source of sound, that is d, what would be the total distance that is travelled by sound before it reaches back to the same observer who is clapping standing at S? Now, you can understand d to go and d to come back, total distance that sound is going to travel is going to be 2d. If I consider speed of sound in air or in that material medium as v, then what would be the time after which we can hear the echo? That is simply time to hear the echo. How much is its value? So, time if I take t, it can be written as distance by velocity. One can understand in this case the total distance travelled will be 2d and velocity or speed of sound is v, then automatically we can write directly 2d by v, that gives you the value of t. In other words, you can even rewrite the same, what should be the minimum distance that should be maintained between the sound producing source and the reflector to hear a very clear echo. That of course d we can write it as Vt by 2. If I consider speed of sound in air as 330 meter per second at 0 degree centigrade, then directly we can understand the minimum distance that is needed are required between source and the reflector for hearing a clear echo, that D is equal to 330 into persistence time of hearing, that is 1/10 of a second, whole divided by 2, that now becomes 16.5 meter. So, what one should understand from this description is the minimum distance that is to be maintained between the sound producing source and the reflector to hear a very clear cut echo, that of course is 16.5 meter, which is not universal value. Like when we consider the speed of sound in that medium as 330 meter per second, then only it becomes 16.5 meter. For example, if I consider the same speed of sound as 340 meter per second by any chance, then I can understand the value of D now becoming 17 meter. So, whether it is 16.5 or 17, whatever, that all depends on the speed of sound in that material medium 1. And persistence time of hearing for almost every human ear, that of course is 1/10 of a second. So, no need for us to change this value. So, minimum distance is 16.5 meter, what we can consider. That is the concept. Fine. Now, when we consider this echo, what are the different applications based on echo they can ask? Let us take 2-3 cases. Very first case, a car moving at VC. So, let us consider one example here, a car moving at VC towards a hill or a wall. Now, you can understand well, this one is the hill there or the wall, whatever we are considering, and the car is just moving towards. This is the car, which of course is moving with a speed VC. When it is at a certain distance D from the wall, the driver has blown the horn, and of course he is continuing towards the wall. He is moving still with the same speed. When he is just blowing the horn, when the car is at a distance D from the wall, what time it takes for him to hear the echo? After what time he can hear the echo? That is the question. So, directly one can understand here the time after which the echo can be heard will now be the same formula we have to take up. T is equal to 2D by V. That is actually the concept, what we can understand here. Now, in this particular case, what exactly is the time after which he can hear the echo? So, I can say that this will be 2D with what velocity? V plus Vc. Then, what must be the distance at which he is blowing the horn? Suppose they may ask you. That time we can write it is V plus Vc into T by 2. So, at what distance he can blow the horn so that he can hear the echo after T seconds? That is a question they may ask you. Or else, after what time, by giving you the distance at which the horn has been blown, they may even ask you after what time he could hear the echo. So, two cases over here, only formula is same in a different way, that is all. Only the format is different, that is all. So, if you look at this one, car moving at VC towards the wall, that is the concept. By any chance, if the car has started moving away from the wall, then what happens? Very simply speaking, this becomes negative. So, for example, if I write the same concept over here, that is when the car moves away from the wall, once again at VC, the same speed. then you can understand directly that T is equal to 2D by V minus Vc. In other words, you can even write the same equation this way also, that D is equal to V minus Vc into T by 2. This is the equation for distance at which that fellow has blown the horn for him rather to hear the echo after say t seconds. This is actually one of the applications what they can ask you as far as echo that is concerned. Usually this concept of echo, the technique of echo we use to determine the depth of the sea at a particular place. That's what actually we call it as sonar, sound navigation and ranging. So by considering this technique, one can directly understand or even calculate the depth of the sea at a particular place. One of the better examples for that, when I consider this echo, what we used to have here, this is the surface of the sea. Now there is a transmitter over here. Transmitter for what? Transmitting the waves, which are of course sound waves. And here we will be having a receiver. And the distance between these two, say, is taken as d. One is a transmitter, one is a receiver. Now when you are just sending sound waves, sound wave of course travels all the way, strikes the bottom of the sea and now reflects this way. We definitely can understand now this is the total distance what one has to call it as the depth of the sea at that place. In fact, for doing this one, we use ultrasonic sounds, ultrasonics. But whether ultrasonics are visible, this one, the direct hearing waves, ultrasonics or infrasonics, whatever we talk about, they are all going to have the same speed in that particular medium. So what we can understand here is when ultrasonic wave is just striking, this is the bottom of the sea. For example, bottom of the sea. This depth what we are taking it as h, that is the value what we have to calculate. Now one thing you can understand is sound is just traveling all the way and coming out this way. This is the echo which is going to be heard after t seconds. That means the time taken by the sound to leave the transmitter and reach the receiver, let us consider the total time is t. Then one can understand to go down it takes t by 2 seconds and to come up again it takes t by 2 seconds. So t by 2 time to reach the bottom, t by 2 to come up from the bottom to reach the receiver, fine. Now in going down or coming up, if I consider the speed of sound as v, speed of sound, if I consider that one as v, then one can understand in this case what is this distance travelled. If I name this point as O, then distance TO. How much it is? Distance is equal to velocity into time. Now velocity is taken as v here, time is taken as t by 2 here. So how much distance that is travelling just before touching the bottom of the sea now? V into t by 2. What is the t? T is the total time taken by sound to leave the transmitter and reach the receiver after striking the bottom of the sea. That is the concept. So when you take this one as Vt by 2, this distance is known and this distance is definitely d by 2. This will again be d by 2. Total distance is d, means this is d by 2, this is d by 2. And what is this distance now? It is simply Vt by 2. Now I know this distance, I know this distance. What is the depth of the sea? Depth of the sea we just want. That in this rather figure, it is represented by h. So h can now be written as root over Vt by 2 whole square minus d by 2 whole square, applying Pythagoras theorem. So what one can write in this particular case? You can write the same equation this way: v square t square minus d square by 4 whole under root. Out of that one, v is the speed of sound, we know, and d is the distance between the transmitter and receiver. That is the point we have to understand. Here d now stands for distance between the transmitter and receiver, that is d. And what is this t here? Total time taken by sound to reach the receiver from the transmitter, that is TO and then OR, the total distance, what exactly it is traveling, in what time it is going to travel, that gives you the value of t. So when you know this formula, directly one can understand what is the depth of the sea at that particular place. That is one more application as far as echo that is concerned. One more application as far as echo that is concerned. They can describe a simple problem this way. There are row houses. Here also we have row houses. And there is a road directly in between these two, and a car is just traveling right in the middle on the road. Let us now consider there is a car that of course is traveling this way, right? It is the car what that is traveling along this one. With what velocity? Let us consider the speed of this car as Vc. Now one can understand when this car is just moving on this road, when it is at this point say A, that driver has blown the horn. And of course he is continuing his motion like that with a constant speed. After reaching this point B, the same driver could hear the echo of that horn what has been blown by him earlier. So when the car was at A, the horn was blown. When the car has reached this point B, then he could hear the echo. Now this is actually the description. If time after which the echo is heard is known to us, then one can directly calculate what is the width of the road in between the row houses, or what is the distance between these two row houses which are parallel to each other. That is what actually the concept we just have to finalize. So when we talk about this point A, first this sound goes to the row house and it just comes back after the reflection like this. One can understand the moment sound is reaching from A to O and then back from O to B, in the same period of time, this car is just moving from A to B. So what one can understand in this particular case is, what is this distance AB? If I write that distance as D, what is the distance officially? It is speed of the car into time taken by that sound to reach him again in the form of an echo. In other words, we can say that T is nothing other than time after which he could hear the echo. That is the point. Now this is the total distance AB, what we have calculated, where Vc refers to the velocity of the car. Now from A to O, speed of sound is V, and time taken by sound to reach from A to O is T by 2, only half the time it takes. Then what would be this distance? This distance is simply Vt by 2. That distance I can call it as x. So this x distance, this is x distance once again, that is x is equal to again Vt by 2. This is Vc into T. Then one can directly understand from this description, when I just draw one perpendicular from this point O, or the perpendicular distance between the path in which the car is moving and one of the sets of row houses, then this distance, if I call it as D dash or D1, twice this D1 gives you the total distance between the row houses. So one can understand from this total description, right? Width of the road, suppose if we want, that now should be twice D1, this plus this, these two distances are equal. So twice D1, then how to calculate this value of D1 is the question. You can understand this distance is x Vt by 2. This distance total is D. Now what will be this distance then? Vc into T by 2. So you can now understand what is this D1 now. According to Pythagoras statement, we can write root over Vt by 2 whole square minus velocity of the car into T by 2 whole square. In reality, you can now understand this road distance, width of the road, that is equivalent to Vt by 2 whole square, V square T square, we can write minus Vc square T square by 4 whole under root. So when I just take the total width of the road as W in this case, so this implies W is equal to, I directly can take this into 2 we have. Now T square I can take common, T square by 4 root, if I bring it out of the root, that becomes T by 2 into 2 root V square minus Vc square. This 2 getting cancelled, what will now be left over? Width of the road will now be, it is T root V square minus Vc square. This is the formula. What is what out of it? You directly can understand. V in this particular case is speed of sound, and Vc in this case is speed of the car. And what is this T here? Time after which the echo is heard. That is the concept. So when you have been asked an application based on echo like this, one can estimate what is going to be the width of the road directly, or you can even call it as the distance of separation between the parallel row houses. Like that also they may ask you, but whatever be the question, this is the ultimate formula one need to remember. So, echo whenever we take up, there are certain cases one should remember. One is the total distance travelled by sound before we can hear that echo, that is always going to be twice the distance between the source and the reflector. Then automatically the speed of sound V can be written as 2d by t. So, one can understand that equation straight away, and based on that you can work out any application, let them give in the form of a problem there. So, these areas one should remember as far as the formation of an echo that is concerned.